I'm from Design Pathshala, so I'll be taking all your Hadoop classes, and all the sessions will be recorded up. And if by mistake any day I forgot to record, you also get a prompt over there the session is recorded or not. So just remind me the session is not recorded today, so that I can start the recording. But by default, the session would be recorded up, and you can view them in future if required, or if you miss the class, definitely you can ask the admin team. They will share you the recordings. So welcome to our session and thanks for choosing us. Definitely I think you would be enjoying the session and you'll be learning a lot of things. So I've been working in this industry from last 12 years and working on big data and related things from last 3-4 years, and have been working with different clients, different e-commerce clients as well. I would request you to please put yourself on mute if you're not speaking up, and have been implemented a lot of solutions for big data and have been consulting a lot of people, consulting a lot of companies for big data related solutions. And I am also providing a lot of online trainings as well as classroom trainings, corporate trainings, taught more than 400-500 people by the date. And so this is all about me. If you have any other questions, you can ask me anytime. So I'll hand over the mic to Basha. You can introduce yourself and do let me know what's your expectation of the class, what specific you are looking for, and anything specific you are looking into the session. Hey Basha, I can just give me a brief introduction and anything you are expecting out of the session, any specific things which you are looking up.
Hey, this is Umesh. I just joined. Is that link working? The GoToMeeting link, is it started?
Yes, Umesh, the GoToMeeting link is started, and you can just click on the link. I think there was some confusion, and people were shared with two links. So use the latest link which was shared to you. That is ending up with 885, and the meeting is already.
Right, I used that one.
Hello?
Hello?
Yeah, sure. I can hear you.
Yeah, there was a lot of noise in the background. Maybe Umesh is trying to join.
Yeah, I'll just keep everyone on mute from my end once we are done with the introduction session, and you will definitely not hear any of the noise. So I'll hand over to Basha. I hope you can hear me. I just require a brief introduction about you and anything specific which you want to say.
Yeah, hi. My name is Basha. I work for Oracle. Before joining Oracle about 5 years ago, I was with Sun Microsystems. I am in the engineering organization of Oracle. I am a Java developer. So what I'm looking from this class is to get understanding of big data in general and the Hadoop framework, so that I just get familiar with the with this new ecosystem. Yeah, that's pretty much it.
Okay, sounds good. Sure. So Basha, I'm putting you on mute, and I'm unmuting Karthik. So Karthik, I think you have dialed in from yeah.
Yeah. Yeah, we all work for Oracle, and I've been with Oracle for over 10 years now, and I'm looking to learn something new and also try to get certified and try to see if I can get a career in that path. So my goal is to learn as much as I can so that I can get certified and also learn the concepts and get better at it.
And Karthik, if you just brief me about your technical background, that will also be helpful in me modularizing the sessions and going in depth.
Sure. So I have been working for almost 18 years, close to 19 years now. I have been developing Java applications, and recently with Oracle I have been doing more of a maintenance kind of work, we still have to dig into a lot of code, Java code, and so yeah, we are good at Java.
Oh, that's good.
That's the only thing we have right now. Yeah.
So that's good. I think that's pretty good. And I heard one more people join in. I think that was Umesh. Umesh, if you can hear me, I can't see you on the web UI, so I can't mute or unmute.
Right, I'm trying to log into it. But can you hear me now? Because
Yes, I can hear. I can definitely hear. Yes.
I have audio, but I don't. I'm now trying to get into this GoToMeeting.
Sure, that will.
Yeah, but I can talk. Well, yeah. So I think Karthik and me work in the same group. Basically, we are in sustaining of Java Suite, which is pretty much like a pretty complex Java J2E like suite of applications. And I think we are same as Karthik. I think I started working from '99, almost like 17 years of experience. So pretty much like in Java and J2E web services whole stack. And work on different verticals of past 10 years. So Suite, on Sun and Oracle. So what I am looking into this training is to kind of like see, everybody talks about Hadoop and big data and like there's a good market trend towards this technology. So I want to understand a little bit more in depth. I know a little bit conceptually, I know what it is and how it works, but I want to kind of get my hands on into it to understand more on how to do it, and if if I want to use it in the future, some other jobs and things like that, that could be useful. So that's what I'm looking for.
Sure, Umesh, I think you will get hands-on after each and every topic which we'll be covering up. So I prefer to give hands-on practice exercises, and that will help you to understand the system as well as give you hands-on on the system. And regarding the certification point which Karthik raised, definitely we'll be covering a lot of technical things, and you can, after completion of this course, you can try either Cloudera or Hortonworks certifications. What are Cloudera or what is Hortonworks? So if these terms sound Greek to you, don't worry, we'll cover all those things. And after end of this training session, I'll give you a real industry program, or I would say a project. And if you people can do that, I am 101% sure you can clear any certification, as well as you can crack any of the interviews across the industry in US. And definitely there's a huge demand of big data and Hadoop related work. Consulting people are fetching nothing less than $250 to $300 an hour, and highly professionals are even fetching more than that. And I also get a lot of such calls and different things. But definitely there's huge demand and huge potential in this field, and next 3 to 4 years are set to be more. Hey, Rajesh, I think you have to download the session, download the GoToMeeting, and most of my students join in from Mac. They don't face any issues, or if you have iPad or something, you can just download the GoToMeeting app, and you can view it there also. Even if you have any mobile, you can download the GoToMeeting app and just use this meeting ID, and you can view and listen to the session. On the Apple, there's nothing specific to Apple on this. You just try to download the GoToMeeting, and just start. Sure, I think Rajesh is there. Okay, so welcome Rajesh. I think his audio is still yet to be started up. So I'll just wait one more minute for Rajesh so that we can hear him also before we go ahead. So you all people, okay, you all are from same company and same project. That's good. So Rajesh, if you can hear me, could you just brief us about yourself, little introduction and anything specific which you are looking from the session? And if you can't speak out, you can just ping on the chat window and I can read it for you. Okay, I think we'll hear Rajesh's voice later on. He might having some trouble. So let's start. I am just sharing my screen. Give me a sec. And I'll just mute everyone, and the people who have joined in from the phone, please mute yourself. And once required to speak, you can unmute yourself. But so I hope everyone can see my screen. If you can't, do let me know. Okay, so I hope everyone can see my screen, and whenever you have to speak anything, you can just ping me on the chat window, and I'll unmute you if required. Otherwise, let's put it on mute. That will be helpful for you as well as for others. So just my humble request. So this is the course content which we'll be covering up in this session, and if you have any doubts or anything on this, do let me know right away. We can try to think of if any changes are required or anything like that. I request everyone to please put your phones or the meetings on mute. Thank you. So I see everyone is here. So we'll be starting out with the basics of Hadoop and what is the motivation behind Hadoop, why Hadoop is in so limelight, why it's in so much demand, and things like that. Moving on to what we call MapReduce. So MapReduce is I hope everyone would have heard MapReduce somewhere here or there in the air. So MapReduce, I'll not put anything complex right now. So MapReduce is just a framework which helps you to process the data in the Hadoop framework. So for time being, just understand this thing. We'll cover everything in detail. So we'll learn MapReduce, and as all of you are from Java background and in the same team, I think it will be pretty easy for you to understand the MapReduce, and it will be pretty easy for you to grasp all those things. Then we're moving on to Pig and Hive. So Pig and Hive are frameworks on top of MapReduce, and at the back end they generate MapReduce code and process the data for you. Then Scoop, Oozie are the framework which help. Scoop is a framework which helps you to import the data and export the data out of the Hadoop ecosystem. Oozie is a workflow engine which helps you to stitch and make workflows in Hadoop ecosystem. And there are some UI tools which help you to visualize the system, reporting tools, and the project. At the end, I'll be giving you one project as I was stating you, and this would really give you a feel of how the big data and Hadoop is used in the industry and how people are using this technology for different purposes. Anyone, anything on this thing on the course detail before I really move on to the stuff? I've just touched on the topics. We'll cover each and everything in detail.
Okay, quick question. So the Oozie and the Hue, you will go through some examples, or it's just a brief introduction?
Hue I will be keep on using from the day 2 of our session. So Hue will touch base because this is a UI. So I'll help you. This will help you in the easiness, as well as from the day 2 I'll keep on explaining you different things in the Hue UI. And Oozie is a workflow engine, so I'll explain you how to create the workflow, and we'll give you some sample workflows. And in the project is designed in such a way that you have to design the workflow. So when you will be designing the code, you have to put in the workflow, stitch in the workflow, so that it can be ran each day, so with a frequency of daily or hourly kind of thing.
Okay, thank you. Mm-hmm.
Sure. So let me brief about the company. So this is so we most of our courses are online, and most of our students are majorly from US. As I was saying, most of our courses are online, so we are mostly into the web-based trainings, but we give physical trainings as well as classroom trainings as well. But majority of our sessions are online, and most of our teachers are experts in their field and working in the respective areas. So this gives trainers and the students basically this helps trainers to customize their courses in what is running in the industry. They are as they are aware of the industry. They can easily understand your problems, and they can give you, or I request everyone to please put your mute. Thank you. So this basically helps them give the real-time scenarios, as well as this makes us little bit apart from other training institutes. We don't have trainers who are just into training field. Each of our trainers are really working in the industry. And this is our motto: learn and apply. So that's the reason after each and every session I'll be giving you hands-on sessions that will help you understand the thing what we have discussed in the class. And we'll be discussing the sessions on your PC. So today will not be requiring it, but from tomorrow, that is from the next class, I request you to join in from your laptops so that you can try out the hands-on thing. And I'll be giving you problem statements, and I might be giving you the session control as well, so that if you are facing any problems, so I can view that and resolve those things. So that is the way we'll be working up. But today you won't be requiring it, but from tomorrow I request you to join from your laptop so that you can do hands-on. We have courses in different cutting-edge technologies, including Hadoop, analytics, R, Mahout, a lot of things. So, okay, so I hope everyone is fine enough, good enough, settled enough before we start up. And I hope Rajesh is also there. So Rajesh, I think we missed you. Everyone briefed me about themselves. If you can hear me now, and if you want to tell us about yourself in a minute, that will be good. Okay, looks like he's away. Not a problem. So, okay. So anyone has any before I start up, I just hand it over again back to you before starting up. So anyone of you want to tell me, or want to speak out, what do you understand by Hadoop or by big data? What is there in your mind, and what do you think this is used for, or anything related to that?
So basically, I have undergone similar kind of training before. My understanding of Hadoop is that it's a parallel processing engine and file system that is efficient in handling huge amount of data and making it more reliable.
Okay, yeah, makes sense. This was Karthik, right?
Yes.
Okay, yeah, makes sense. Anyone else? So Chan says nothing from me. Okay, not a problem. Okay, let me start. So let me give you an example before starting up. An angry father entered into Target store, shouting on his high pitch on the store manager, stating, "How dare you can send maternity clothes coupons to my 17-year-old daughter." And the store manager was just red-faced and would just apologize to the father that by mistake we would have sent the maternity cloth coupons to your daughter, who is just 17-year-old. We are sorry for that, all the inconvenience caused. And after a lot of argument, the father returned back to his home. 10 days back, father called the store manager, again the target store manager told him, sir, I apologize for all the trouble which I caused to you that day. I got to know that my daughter is in second trimester of her pregnancy. So target got to know that her daughter was pregnant before her father knew it. And how the target knew it? Target tracked her shopping history, the clothes which the clothes or the medicines or the food items, different things which she was buying from the Target store, prenatal vitamins and soaps related to that. And based on that, Target found out that the girl is pregnant, and they sent her the coupons of maternity clothes before her father even knew that she's pregnant. So this is how the data processing is happening in the industry. And to process this data, what we require is something called big data or Hadoop kind of ecosystems. So how that is done, there are different things, but this is just an example which I gave to you. Netflix knows which movie you like before your friends even know that. Pandora knows which songs you like, which you might like before you yourself might know that you would like this song. Google can tell you whether there will be a flu in some particular part of USA before even the the municipalities or different organizations from the government knows that the flu is breaking up based on the Google searches which people are doing. So this is how the data is getting processed in the back end, and with the help of the high processing power, people are able to predict different things, and this prediction is based on the algorithms, but how those algorithms are run in the system is with the help of massive parallel processing power of Hadoop ecosystems. How that is done, don't worry. I will talk each and everything in detail. And whenever you have any questions, so Rajesh, not a problem. I'll hand over to you after some time. And so Rajesh just pinged me, he was on mute. So Rajesh, not a problem, and I'll hand it over to you in some time. So whenever anyone has any questions, just ping me on the chat window, or rather than unmuting yourself, that will reduce the disturbance for others. And I'll read your questions, and if required, I'll put you on unmute. So I hope everyone remembers the days of 80s and 90s. Most of you are working in the industry from last 20 years, 15 years. So everyone knows the days of 80s, 90s, even 2000 when there was single PC, and we used to have those floppy disks of 3.1 MB, and later on those floppy disks were increased to 5.1 MB, and I was literally very happy I can store 2 more MBs of the data. Those were the days. At that time, computer operators used to enter the data, and the data which was generated in the system was very, very less, and the processing of that data was not an enormous task. I remember the first PC which I brought was just 256 MB of hard disk. Now 16 GB of RAM is not sufficient for me. So this is the rate at which data is growing, and the processing of data is required. Users are entering data. So I hope everyone can understand this picture which I'm displaying on the PPT. It's not only the operators which are now entering the data into the system, it's the real users who are entering the data into the system. And these real users, when they started entering the data into the system, this data is growing at a massive rate. Facebook, Twitter, LinkedIn, these kind of systems are generating petabytes, terabytes of data each day, and to process this data, we can't rely on our traditional databases or traditional systems. So it's not only the user-generated data, it's the machine-generated data which is also getting generated at a pretty fast rate. Can anyone guess what this picture is doing over here?
Weather reports.
Yes, how this is related to what I was speaking. So what I wanted to show is it's the machine generated data is also generated at an enormous rate, and to predict what would be the weather at 2 p.m. today at Texas, I need to process last 20 years or 25 years of data. So this is an enormous amount of data generated each seconds or microseconds by these satellites, and that data need to be generated every minute to predict what to be the weather conditions at different latitude and longitudes of the globe. And yeah, that definitely you are right. I might take little time to recognize your voices, and so so just bear with me today if I do not recall your names. Any guesses what this is doing over here?
Predicting the prices, maybe, like, the fares of the travel.
Okay, that is also a good point, but my intention was little different. Umesh?
Okay.
Okay, so a Boeing flight with 4 engines, say traveling from New Delhi to Bangalore in India, 2 hours 10 minutes flight, would be generating more than 2 terabytes of data each engine. So if there are 4 engines into 4, this is the kind of data which is generated by a single flight in a journey. So if I find out the mysteriously disappeared Malaysian airline flight, if I find their black box, you can think of the kind of data which I would be processing up to find out what would be the reason behind mysteriously disappearing the flight. These machines are also generating enormous amount of data, and it's not only the user generated data which is there in the system, which is required to be processed, the machine generated data which is much more rapidly growing as compared to that. Then there's a lot of medical data generated at hospitals, and this is used to predict your future diseases, to cure you for insurance and a number of things. And I hope this picture is pretty much clear. But this always recalls me one of the example. Let me again give you one more example. There was one vegetable guy who used to visit in our society, and I used to buy vegetables with him. Then sometimes after some time he stopped visiting the society, and I also forgot him. 6-7 months down the line, I shifted to a new society nearby only, not much far away. And when I went down to buy vegetables, I saw the same guy. I asked him, "You used to visit that site, but you stopped visiting that area. Now you're sitting over here. Any specific reason?" The guy told me, "Sir, over here people are carrying cars like Audis or Mercs, and people have and houses are big, so people have more spending power, and they do not bargain me much, and they buy costly vegetables as compared to that area. So I started sitting at this area." So that guy was intelligent, his geography was limited, his number of items was limited, and he was able to do analysis on the data and figure out which area is best suited for his sales, where he can increase his sales. But think of Amazon. They are selling more than a million of SKUs, that is commodities, each store. And the transactions are more than a million each hour. If they have to do such kind of analysis, they can't do with such kind of processing. They require some enormous processing powers at the back end to generate such kind of statistics. And for all these things, we require some enormous processing power, which is given with the help of Hadoop. How that is given, what is done, don't worry, we'll cover each and everything. So any questions before I move it? Rajesh, do you have any questions? I think you were speaking something, but we were not able to hear you. Okay. So let's talk about the problem with the data and how the data, this problem with the data is resolved. We'll look into that thing. So there are 3 V's about big data. One is called volume, second is called velocity, and third is called variety. So I hope now volume is a little bit clear with everyone. So that this is the volume of data which we have to process to generate different statistics for different things. The whole World Wide Web is sitting up with more than 3 zettabytes of data. Zettabyte is 10 to the power 10. And the Library of Congress sitting up with more than 300 terabytes of data. Facebook, more than 330 petabytes of data. These figures might be a little older, but I'm just trying to give you a picture of kind of data which people are sitting up with. Walmart, just in their data warehouse, I'm not talking about their real database, just in their data warehouse, they are sitting up with more than 2.5 petabytes of data. So think if Walmart have to do such kind of statistics, what kind of data processing they require. That definitely cannot be done in traditional database systems. eBay is again setting up with more than 10 petabytes of data just in their data warehouse. So these are the kind of data on which people are sitting up with, and this data definitely cannot be processed with traditional systems. So it's not the volume which is creating problem in this area. The next major problem is the velocity, the rate at which this data is growing. YouTube generates more than 48 hours of new videos every minute. And if they have to find out or filter out the malicious content which is not intended as per YouTube policies, they have to process 48 hours of new videos every minute to figure out whether the video is intended with the YouTube policies or not. Every minute 571 new websites are added to www World Wide Web, and if Google have to parse them, you can think of the kind of processing power which is required. Facebook generating more than 500 terabytes of data each day. Twitter generating 175 million tweets each day. So this is a great. It's not the volume of the data; it's the velocity at which the data is going is again a big challenge. And it's not just the velocity of this data growth is a challenge. Is the acceleration of this velocity is again a major challenge. That is the rate at which this velocity is growing itself. So the rate at which data is generated in 2009 would be 44 times higher in 2020 as compared to 2009. So this velocity, the rate at which this velocity is increasing, is again a big challenge for us. And to process this data, we require enormous systems. And the third major challenge with the data is the variety of the data. That is a structured, semi-structured, or unstructured data. Structured data is from your traditional databases, Oracle, MySQL kind of systems. Semi-structured is kind of JSON, XML. I hope everyone of you understand what is XML or JSON, because all of you are from Java backgrounds. And unstructured data like text, email, videos, audios kind of data. So it's not only the data or the rate at which data is growing. The next major challenge is the variety of the data which you have to process to come up with different statistics. Any questions? Anything? Okay, let me go ahead. So Rajesh, I'll put you on mute. Whenever required, I'll unmute you so that we don't hear any disturbances back. So let's see how companies are minting money on this big data as a whole, and what is happening in the industry before we really look into the system. So predicting what customer wants before they ask for it. If you log into LinkedIn or log into Facebook, before even you search for your friends, Facebook will suggest you the friends, or LinkedIn will suggest you the friends. So this is what you might be looking for before that is suggested to you. You log into Amazon based on a previous search history, the product would be suggested to you. So companies are trying to predict what their customers would be wanting up before you really ask them for ask them for the real product. Then marketing campaigns, people are doing targeted marketing campaigns, personalized campaigns to attract new customers, and to not only to attract new customers, to retain their existing customers. Companies are spending enormous money on these marketing campaigns to attract And not only the marketing campaign, you search for any product on say Flipkart or Amazon, close the browser, go to any other damn website in the world, on left hand side or right hand side you will see the advertisement of the same product somewhere somewhere here and there. So you can think of the kind of processing power which is required in the back end, how that is predicted that you search that product and now Google is displaying you that advertisement. Improve customer services. People are not only using the data to retain the customer market, but to improve the customer services so that they are loyal to their customers and their customer do not leave them. So I'll just give you one example. I brought one product from a company called Flipkart. This is one of the major e-retailer in India. The product was a little faulty. I called their customer care, but I hope to understand there won't be any responses. So what I did is I just posted on the Facebook page, complain and some bad words about the company. Within even in less than 30 minutes, I got a call from Flipkart marketing team, marketing or sales team, whatever the team was, stating, sir, please remove the comment from the Facebook. We'll replace your whole product and we'll refund your money as well. So in 30 minutes, they not only process the post on the Facebook, they even process the negativity and the positivity of the post. Based on the negativity, they figured out this is a customer of Flipkart, and they not only figured out this is a customer of Flipkart, they also figured out this customer brought some product and he might be facing some trouble with that product, and he also found out my phone number and everything and called me in 30 minutes. So this is a kind of, not only the improvement of customer services, people are much aware of their social graph and sentiment analysis on the websites, social graphs, as well as improving the customer services. And at the back end, this kind of systems are coming up in picture, which is helping companies to do this. Fraud detection, again majorly used by banks. So to predict frauds in the financial industry, Hadoop is highly used by different banks. So for example, say each month some $10,000 are credited to your account as a salary, and some certain months $1 million are credited to your account, and after 3 days those are being transferred to some other account. So there's something fishy which bank would detect in such a scenario, and they will generate some alerts, and these alerts need to be submitted as an anti-money laundering reports to the different governments for different compliance reasons. And if banks fails to do so, they are fined high. Citibank has been fined to a lot of times millions of dollars by the US government for not submitting such kind of reports for some customers. So today there's because of different laws and different things, banks have to do such kind of deductions, and at the back end these kind of systems are doing batch processing and finding out the frauds in the system. So it's not only people are using data to increase the customer services or processing the data. They are also using this data to excite the customers themselves. For example, there's a company called MyFitnessPal. What they do is they sell milk products or dairy products. So based on what you buy from them, they find out what are the calories you consume, and those calories are updated into your profile on MyFitnessPal itself. So if your calories are getting updated on their website, your data is maintained by the website, you become loyal to MyFitnessPal and you buy products from them only, so that you can maintain or you can see your calorie graph. So just by making customers excited by their own data, people are trying to make customers loyal to themselves. Companies are trying to make them loyal to themselves. Identifying customer pain points and solving them. I hope everyone would have traveled many times international, and the major problem which people face while traveling internationally is losing their baggages. So what interesting data airline does is they created an app called Track My Bag app. What you have to do is you just snap your bag, the tag on your bag, and upload it on the app. Your app will track where your bag is, even if you had a halting flight and your bag by mistakenly deboarded at a halting station. Your app will tell you where your bag is, how much time it will take for your bag to come up. So although your bag losses cannot be reduced, but this will help you to track your bag. And if you can track your bag, you won't be calling the customer care and again and shouting on them. And you might be a little relief that your bag at so and so station and will be reaching you at so and so time. So this is the kind of data people are using up and trying processing it up, and at the back end this kind of ecosystem are used up. Research and development, sentiment analysis. I just told you an example. Research and development. Obama administration announced more than $200 million research project in different departments, including Department of Defense, National Institute of Health, the Department of Energy, U.S. Geological Surveys, and this all initiative is related to Big Data Research and Development Initiative by Obama administration. So it's not only the companies who are spending a lot of money into this area, it's the government who are also spending a lot of money in Hadoop and big data related research, and that's the reason these words are in high limelight, and there's an enormous potential in this market for at least next 5-10 years. Any questions over here before I go it?
So based on the use cases that you have provided, it seems like it's kind of like more of like an analytical process for gathering a huge amount of data and then processing it on some pattern recognition, so like AI kind of methodology involved here, right? Is that right?
So Umesh, you raised a good point. So Umesh, there are three things basically. One is called algorithms, which are doing this kind of AI or machine learning or analytics, and second is to run those algorithms. So those algorithms are written in different languages, including R or machine learning languages, and even if those algorithms are written, you cannot run those algorithms to predict these kind of patterns on the data, and because the processing power which is required to process the data for those algorithms, you require enormous amount of processing power. This processing power is given with Hadoop ecosystems.
Right. I think we have similar kind of concepts in IEP and CEP. We actually can like event processing engines that we have in the market. They can do the same kind of thing, but I think the scalability and the volume that is coming in, I think Hadoop plays a big role in there, I guess.
Yes. So when you write a Java code, the next question your manager or your whomsoever you're reporting to ask is how scalable the code is. Right. What happens if 1 million customers will trigger my website? What will happen to my website? So the next question comes up is the scalability. But when you write code in Hadoop or any program or any data processing thing in Hadoop, this question would never be raised, because the system handles all those complexities for you. You have to interact with the system in a simple language for MapReduce or similar to that, and the scalability and things like that are out of your scope, and that everything depends on the ecosystem and how that is taken care of. That those things will be clear in today's or tomorrow's class. But yeah, definitely those algorithms are there. So there are different sessions for analytics and things like that. We also have different programs under the umbrella brand name of Pathshala. But
so will you be also touching the security aspect of Hadoop, like because you talked about accessing data from other servers and things like that, like for getting the patterns, and so will there be like a security kind of concept that you will go through?
Okay, so Umesh, this is a developer session. Here we will be looking at most of the developer related things. The security are enabled like Kerberos and the different things. Those things are touch base in the Hadoop admin related classes, and this is a Hadoop developer session, so I'll not be touch basing the security related thing. But if you have any specific questions, you can always ask me. I know a lot of the admin thing, but I am not an expert admin guy.
Sure. Thanks.
Okay. So these things we just discussed right now. Facebook setting up with 30 plus petabytes of data, and that is used, not only to predict your friends, to suggest you different products which you're searching, the advertisements inside your, now these are inside your, what do you call that, scraps, LinkedIn, Amazon, Trito is using your, research, your past history of patients to suggest them different treatments and like things like that. Few years down the line, decoding a human genome took 10 years for people. Nowadays, it can be done in less than 7 days. And this figures are indeed old. I was looking into different companies, and now this is done. Now people are decoding more than 100 genomes each day. So this is the kind of processing power which people have got with the help of Hadoop and related systems. So let's look into the market. So this is the kind of Hadoop market which is increasing. This is increasing at the rate of 1000% each year, and expected to be 53 billion US dollars by 2017. In 2011-10, the graph, I'm not forgotten to draw it, but this is so small that you can't view it. So this is the data which I got from Webicon. And the rate at which this industry is going is enormous, and there's huge potential in this industry for next 4 or 5 years down the line. For next 4 or 5 years down the line, and after that, I think this would be common like Java. So these are the different job opportunities in this market. So based on your expertise, which I heard from all of you, I think this is the best suited role for all of you. If you get some expertise in this area, and there is huge demand for these kind of options, architects or things related to that. And data scientist is what I think, Umesh, you were talking about right now. So these people interact with the system, but write algorithms to do data science. We'll be covering up little bit about this thing, data science, but will not be going into details of how the analytics is done on the data. But I'll give you a feel how the analytics is done on the data. But this class is not intended for doing the analytics of the data. And Hadoop administrator are the people who are doing the setting up the cluster and things like that. So there are different sessions for Hadoop administrator. Anything on this slide? Anyone want to ask anything? Okay. So this is a graph for init salary which I just copied from somewhere. This is a graph which I copied again from one of the websites. This is the job graph in USD of January 2015. Salaries in different ranges for different years of WorkX. So this is where I think people are. So these are different roles, and this is at Hadoop median salaries. Okay, so let's look into the little bit history of Hadoop before we look into the technicalities of the thing. So I hope everyone knows Apache. Is there anyone who does not know Apache? I hope everyone would be using different jars of Apache. Okay, so I'm just assuming everyone knows Apache. So the Hadoop basically started, okay, before Hadoop. So basically there's a project called Apache Lucene, which was started by a person called Doc Cutting. He was the manager who was managing this Apache Lucene, And this Lucene was a full-featured text indexing and searching library. So Lucene helps you to index your text and then do search on the text. So inside Lucene, they started another ambitious project called Nudge. So this was again started by dog cutting in Apache. So Nudge was a kind of web crawler which crawls your website and parses your HTML data and create a link graph on your HTML pages and things like that. And then then the data was stored in Lucene. Lucene used to index that data, and they were trying to create somewhat similar to Google. So this is the ambitious project of Apache which was going up, but when they started this Nudge and they started to pass the whole World Wide Web, pretty soon in a month, Lucene raised questions to the management and different steps that to store such an enormous amount of data and to process the whole World Wide Web data and then to index the data. It would not be possible with a system which we have. We have to do a lot of vertical scaling in the system, and just to maintain that infrastructure, that the cost would be millions of dollars just for the maintenance of the system. But this was one of the ambitious project of Apache. The management gave him a go-ahead, and he started with the vertical scaling of the systems. I hope everyone understand the vertical scaling. If you do not, just ping me on the chat window. And he started vertical scaling of the systems, but pretty soon they just saw the bottlenecks and they were not able to proceed because there's a limit of vertical scaling. So at the same time, Google came up with their white papers called Google File System and MapReduce framework. Lucene, what do you call that? Dog cutting read that white paper and designed something similar to Google File System, what we call HDFS, Hadoop File System. What is Hadoop File System? Don't worry, I'll talk about that thing. And he used this framework and designed something similar to that. And then Yahoo hired this dog cutting, and I hope everyone can understand what is the reason Yahoo hired the dog cutting. Yahoo, biggest rivalry of Google, and when they saw that something like Google is being created by this person, they hired dog cutting, and later on, most of the Hadoop related development happened in Yahoo. So Pig, the programming language, is designed everything in Yahoo. Uzi is again Yahoo highly contributed to Uzi. So a lot of development of Hadoop and its different pieces are developed in Yahoo. So anything about this? Any questions? Anything? Okay, I'll give you a quick mathematical calculation problem. A simple mathematics question, 6th class mathematics question. But I want an answer from every one of you. So say this is a machine which has 1 terabyte of data. I want to read 1 terabyte of data from this machine. The hard disk has 4 I/O operations and a speed of 100 Mbps. Each operation has a speed of 100 Mbps. So simple SATA, your normal SATA has a speed of 100 Mbps, and normally it has 4 I/O operations. I have to read this 1 terabyte of data from my hard disk. I want each of you to do a quick calculation to find out how much time I would be requiring up just to read this 1 terabyte of data from this machine with 4 input-output operations. A simple mathematical problem. I just request you to do a small calculation and ping me the answer on the chat window.
Yeah, hi. What is the question again? Sorry, I was on.
Okay, sure.
The call.
So the question is pretty simple. This is a machine which is displayed on the screen right now. It has 1 terabyte of data in the hard disk. Hard disk has 4 I/O operations, input-output operations, and each I/O is 100 Mbps speed. So four I/O lines, and each line is 100 Mbps speed. I want to read 1 terabyte of data. How much time I would require just to read 1 terabyte of data from this machine?
25 seconds maybe?
Not a correct answer. So Karthik said 10 to 15 seconds. No. Rajesh said 10 seconds. No.
So 4 IO operations, each IO takes, can read 100 MB data per second.
1 TB data. 1 TB, not GB, 1 TB data.
Yeah, 1 TB data. So no idea.
Okay, so I got at least 2 guesses from one from Karthik, one from Rajesh, and Basha, Umesh. Just a guess. Any guesses? Karthik said 1 GB. I was talking about TV, Karthik.
So it could be maybe around like 20 to 30 minutes because it's actually one machine.
Yeah.
So because the CPU is going to split across 4 different IOs, so it's going to be slow.
So okay, just leave about those complexities for timing. Let's say we are just reading it directly from this SATA machine. So yeah, definitely it takes around half an hour, even more than that, 45 minutes just to read this data. Now let's look at the power of parallel processing. So just to read this 1 terabyte of data from the normal SATA hard disk, so this is the speed of your normal SATA on your laptops, which is normally has 4 IOs. It requires 45 minutes just to read 1 terabyte of data. Now, so there is something called terabyte sort benchmark. This benchmark is used to basically used as a benchmark for Hadoop ecosystems. So Yahoo sorted 1 terabyte of data in 209 seconds, and that was a record which Yahoo broke of Google, which sorted it previously in 297 seconds. So they not only read that data, they processed that data, and they repersisted that data in the hard disk, and everything was done in 209 seconds, approximately 3 to 4 minutes. So this is and what they use for this is they use a cluster. The cluster had normal machines. Each machine has a configuration which is very much similar to your laptops on which you want to be using right now. 8 GB RAM, 2 quad-core processors, and this cluster was comprised of such 910 nodes. So everyone knows what is a cluster. Before I go ahead, if you don't understand the cluster, then nothing in this class would make sense for you. If you don't understand cloud or cluster, do ping me right away. So Yahoo not only read that 1 TB data in just 3 to 4 minutes, they even processed that data and reprocessed that data in 209 seconds, which took just 45 minutes to read on a single machine. And how that was achieved is achieved with a parallel processing, which is done across 910 nodes. So how that is done or how that is achieved, let's look into this. So this machine took 45 minutes for me to read the data. Now what I do is I distribute that 1 terabyte of data across 10 machines. So each machine is now setting up with just a part of the data that is 1 by 10 terabyte, approximately 1 GB of the data. And now I have to, and each machine is having same operations, same speed, same everything. Now I hope everyone can answer how much time I would take just to read 1 terabyte of data from this cluster. I'm just reading the data. Don't worry about the complexities of the network, transferring the data of the network, all those things. Just reading the data. It will take me 4.5 minutes. So now my data is distributed on the cloud or on the cluster. It just took me 4.5 minutes to read that data, which was previously taking me 45 minutes.
Yeah, but how we can actually achieve the guarantee that it's going to be distributed across 10 different machines?
Sorry, who was that?
This is Umesh. Like
Umesh.
we
Okay.
have 10 machines, but there is no
Yeah. Okay.
guarantee, right? Like
Yeah.
if it's a
So Umesh,
cluster, we cannot.
yeah, Umesh, if you, I can answer a question right away, but if you can park your question for an hour, and that will give you a real picture how that is done. I'll be covering all those things in some time.
Sure.
How that is guaranteed, how everything is done. Everything, I'll be covering each and everything in detail, slowly and slowly. I request you to park your question for some time and just keep that handy. Ask me again once I reach
Sure.
this slide. If your
Okay.
question is not answered. Okay.
Thanks.
So definitely that is a much valid question, but I'll cover all those things. So if we just forget the complexity about transferring the data over the network and how that data is distributed and all those things, for time being, look at the power which we get just by parallel or distributing the data across the cloud or clusters. So this is how first thing happens, how we achieve a parallel processing. Your data is distributed and we do a distributed processing on the data. How that is done, we will look into all those things. Second thing what is done is distributed file system. So what is distributed file system? Say these are my 10 machines. Out of these machines, say one machine is sitting up with my design Pathshala / project. One machine is sitting up with my design Pathshala images. One machine is sitting up with design Pathshala software. One machine is sitting up with design Pathshala website. But me as a user, I can't remember which machine is sitting up with which data. So there's something called distributed file system. So there's something called master node or the name node. This name node maintains all this metadata, what is lying where, and I as a user just give the namespace of the cluster / my file or the directory and query this name node or the master node from a cluster, and this node then get the data for me. How that is done in detail, we'll look into all those things. I'm just giving you an idea. Practically, I do not really talk to this machine, but I'm just giving you an idea how that is done, so that gives you a picture. So whenever I have to access images, I just say dbglobal.in. This is my namespace of my cluster /home/images. So this will query this machine, and I'll get the data. So these are the two things. One thing is my data is distributed across the machines. How that is done? Wait for a few more minutes. And my data is, I don't remember where my data is. It's the responsibility of the system. Figure out where my data is. I just query my system. My system will return my data. So my data is managed by the system. How that is managed, we'll look into all those things. Any other questions on these two slides?
So does each node is aware of these namespaces, or only the master is aware of the namespaces?
So the cluster namespace is when you install Hadoop, you define the namespace for the Hadoop ecosystem, and each node is aware of the namespace, but this master is aware of which data is lying there.
Okay.
But these things will be a little bit more clear when we will move on to the next slides. Okay, before that, who's using Hadoop? So these are the kind of clusters which people are using. This is the kind of file system which help you to find out where your data is lying. So if you look at Yahoo is using a cluster of more than 42,000 nodes as on 2011. LinkedIn using 4,000 nodes plus cluster. Facebook, this data is older. The cluster size might be much higher than this now, but this is the kind of cluster which people are using up. And because of these clusters, they are able to process such kind of data. So by now, although I really do not like formal definitions, so you will really find these kind of definitions, but this is really required to put it over here. So I have placed it over here. Hadoop is a framework for distributed processing. Your data is distributed and the processing is processing and done distributedly on large data sets, on large clusters of commodity computers using simple programming model. So first thing, let me explain the definition. So this data is divided across a cluster. How that is done, we'll look into that thing. But when you process your data, you not transfer the data over the network. What you do is you just transfer the logic to process the data across the network. So you can think of the complexity if I traverse that whole 1 terabyte of data to my name or master node and do the processing on the master node and then transfer the results. The kind of again I'll be wasting that time over the network which I have saved by reading in reading the data. But the logic to process the data would be very, very small as compared to the data. So what we do is we transfer the logic across the cluster. How that is done, don't worry about those things. We transfer the logic to process the data across the cluster, and that the logic is then ran on the data, and we just get the processed output from the different nodes to the master node or to some node which is managing all those things, and that is returned to the user. So that is one thing, we never transfer the data across the cluster, only the logic which is transferred across the data. And as you can see in this example, this thing which I made, Yahoo processed that whole data with something machines which are pretty normal kind of thing, or pretty normal or pretty common configuration hardwares. So these machines are called commodity hardwares because these are pretty common and kind of commodity. So these machines are called commodity hardwares. So all the data is kept on commodity hardwares, cheaper machines, and you with the help of these cheaper machines, you achieve parallel processing. Your data is distributed parallelly, and you do the processing there only on the machine where the data is lying. So Hadoop is a framework for distributed processing. Your data is distributed across the cluster and you send the logic just to process the data. So your data is distributed across the cluster and you do a processing in a distributed manner on large data sets. Now you understand the large data sets across large clusters. Now you understand the large clusters. The example I gave you for the Yahoo. Of commodity computers, because these computers are pretty cheaper machines as compared to your vertically scaled servers. Using simple programming model, that simple programming model is nothing but your MapReduce. And this Hadoop as a framework is pretty simple. It can fit any kind of data. I'll talk in detail about this ecosystem and how this framework, everything. And this is an open source framework implemented based on the paper of Google file system and Google MapReduce. So does this make sense? Does this definition make sense to everyone? Hadoop is a framework of distributed parallel processing of large data sets across large clusters of commodity computers using simple programming model. So what we do is we never transfer the data across the network. We just transfer the logic to process the data, and that's the beauty about the system. As we transfer just the logic, we save enormous amount of time over the net or on network transfers and network cost, and that is the beauty of this cluster. How the data. And that's the beauty of the system, and how the data is distributed. I'll just talk about this thing in a few minutes. Any questions? Anything?
Yeah, can you elaborate on that point? Like when you say data is not transmitted, but only logic is transmitted, what does it mean?
Okay. So say I have a data, for example, say I have a data of my sales. Thank you. So I have a data of my sales, and that is a data from, say, Amazon, and that is placed in Hadoop cluster. I want to process the data and figure out the potential markets or the stores where the sales is pretty high or something like that. So I'll just write a logic to figure out the sales volume for each store, and I'll just transfer that logic or put that logic in my cluster. How they would put that and all those things, don't worry about those complexities at this point of time. I just put that logic in my cluster, and that logic is transferred across the nodes where the data for Amazon is lying, and that logic runs on that data, and the output of that logic is just transferred of the network to your main node, which is doing all this management for you, and that output of that logic is then segregated or aggregated together on that main node and returned to you. I explained it.
Nodes will have access to this.
Yeah.
So all the nodes will have access to the centralized data, but that will be only acted based on the slicing of per node, and all the data gets basically a master-slave kind of concept here, right?
Not exactly master-slave kind of concept. There is one active node which maintains the whole cluster, and rest all nodes are data nodes where the real data is stored. Okay, so when I put any file in the system, that file is divided across different nodes. And so say this is a cluster, and these are the different nodes in your cluster. So when I put any data in my cluster, your data is divided across different nodes. Each, so say if I put 1 terabyte of data, that will not be placed on disk 1 only, or that will not be placed on disk 2 only. That was divided across different disks, and a same copy of data would be available at least and on 2 more disks. So the data is replicated with a replication factor of 3 by default, and this replication factor is configurable, but the bare minimum which is suggested is 3. So your data is not only copied on different nodes, a part of the data, but that part of the data is copied, 3 copies of that data is maintained across the cluster. Why, how, I'll explain all those things.
Okay, I think when we go further, I think in detail, I think I'll get.
Yeah, I think next 15 minutes, I think your question will be answered in next 15 minutes. Yeah.
Sure, thanks.
So, what makes Hadoop especially useful? So, scalable. As you can add number of data nodes in the cluster, as I have shown you, that the nodes could be added into a cluster anytime. So that makes the system scalable. Whenever you require more processing power, you can add nodes to the cluster, and that makes your system scalable. Economical, as you are using the hardware which is pretty cheap compared to your normal laptops or desktops which you are using right now. I hope everyone can hear me, right?
Yeah, we can hear you.
Okay. So as the hardware which is used in the cluster is pretty cheap, and that's the reason that the system is economical. Efficient, why? Because you do a processing across different nodes. So your data, you basically do a distributed parallel processing, and that makes your system efficient. And and the data is also distributed across, so that so your system is reliable also. So if say one node which is having a copy of my data goes down, which is pretty common, the copy of that data is available on different node. So that makes my system reliable. Even if some node goes down, a copy of my data is available somewhere else, and I can do a processing on that data. So that makes the system reliable. So that's the reason 3 copies or bare minimum of your data is maintained in the cluster. How that is maintained, I'll explain in a few minutes. Yeah, go ahead. Sorry, I can't hear you. No, Basha, I can't hear you properly. You can just ping your question on the chat window. I'll read it for I'll read it for you. Okay, how it is different from Elastic Cloud. So Elastic Cloud, if you're talking about it in terms of Amazon S3 or something like that, they are also running on the same concept. They are using same things. They are Hadoop is an open source, and they might have changed something here and there. So at the back end, they're using the same concept. Instead of SDFS, they call it S3. Instead of cloud, they call it Amazon Web Service clouds. So it's almost similar to those things, Elastic Cloud, and the system which you create is again is not elastic as Amazon gives you the flexibility. Here you have to manually add the nodes or delete the nodes, but definitely is very much similar to Elastic Clouds, what Amazon calls it or other providers calls it. Does it? Okay. Okay, so let's look at a few assumptions on which Hadoop ecosystem is really created and how that is achieved. So they say hardware will always fail. You can't stop hardware from failing. No one in the world can stop hardware from failing. So hardware will always fail. Yeah, and that's the reason your copy of the data is maintained across a cluster. That is one way how they achieve this thing, and there are a few more things. I'll talk about those things in detail. Then application needs read many times but write once, because when you are dealing with such enormous amount of data, you are not using Hadoop for transactional data transactional systems, or you are not using Hadoop as a transactional system. You're using Hadoop as a batch processing system, but those days are also gone with the kind of current processing power which you're getting from Hadoop system, and things like Scala, Shark, Impala, and different things. People are nowadays using Hadoop ecosystem as a transaction system also. But the system previously was designed for batch processing and designed under the assumption that you'll be writing your data once and reading many times. And the third major bottleneck is I/O. Your I/O will always be a bottleneck for you, and that has to be reduced. So, so basically, these are three major assumptions on which Hadoop ecosystem was created. And this point I've just told you, move logic rather than the data. So this helps you to reduce the network cost. How I/O is reduced, I'll just talk about that thing. So I'll talk about the I/O on this slide, how you reduce your I/O. So, but to give you an idea, so all your data is divided into blocks, and the normal block size in the Hadoop system is much higher, that is 64 MB to 128 MB, as compared to your systems like Unix, where it's very less. So when you read the whole block, you reduce the seek time. And when you reduce the seek time, the 50 to 60% of the time which is wasted in the I/O is the seek time. And if you can reduce the seek time, you can definitely reduce the I/O time. So what Hadoop do is they divide your data into blocks, and the block sizes are very high as compared to any other file systems. And as the block sizes are very high, the seek time is very less. And if the seek time is very less, the I/O time is very less, because in most of the systems, most of the file systems, your 50 to 60% of I/O time is your seek time. Make sense to everyone? Is it going? Am I basically? Are you able to follow me, or I'm just talking nonsense till now? Right? It's making sense to everyone. Just a quick yes, no, okay would really help me.
Yes, it's okay.
Okay, Karthik says yes, Chan says yes, Ramesh said yes, Rakesh, I hope yes also from you. I'll myself assume yes from you.
Maybe I think when you said like it's going to divide into blocks, one data, how do we actually manage the the sequentiality of the data? Like is there like timestamp that is added or like blocks number, so that it can be the continuity of the data has not should not be disturbed, right?
Yes, definitely yes. Okay. Okay. So, Umesh, I'll again write your second question, and I'll answer that also. Before end of the question, end of the session, I'll answer all the questions. Sequentiality of data, and there was one more question which you asked. What was that? Something you asked, which I told you your question would be answered by this slide.
I'll ping you once I remember it. I don't remember now, so
hopefully that should be answered by now. But if not, just ping me.
Yeah.
Right. So the sequentiality of the data, how that is maintained. Okay. So I have to explain the system before I can answer a question.
Yeah. The other question I had was how do we distribute the data across like multiple nodes and having the guarantee achieved, so that the same data is basically not processed by multiple nodes.
Okay.
I think that was another question, I think.
Okay. Not processed by multiple nodes. Okay. So both of your questions require me to explain you the system. So just wait. I'll try your questions are answered in today's session. If not, and tomorrow's session, I guarantee all your questions will be answered. I've written them, and I'll recall you these questions now. So let me explain the system, and then only I'll be able to answer your question. So regarding your first question, sequentiality of the data that is help or that is achieved with something called name node. How? I'll explain those things. So basically, if you look into the system, this is how your system looks like. This is Hadoop 1.x. Hadoop 2.x is little different from this, but let's understand the Hadoop 1.x. So once you understand the system, 2.x would be easier for you to understand. So this is your system looks like. There's something called master node, which I was saying in my previous slides. That is called name node. So there's something called name node. Then these are your data nodes in the green, where your real data is stored. So all your data, whatever you put in the system, is stored in these data nodes only, nowhere else. Name node never contains any of your data. It just contains the metadata of your data. What is metadata? That is, which data is lying where, the stats about the data, like how many blocks your file has been divided into, where those blocks are lying, which data nodes are keeping the copy of the blocks, and things like that. And when your name node stores this metadata, this is how your sequentiality of your data is also achieved. So name node knows everything where your data is lying, what blocks, which blocks are associated to which file, and things like that. And in this metadata, only the sequentiality is achieved. So I hope this answers your first question, which you were asking, Umesh, right?
Yeah. So basically, you have an indexing of all the nodes in the metadata, and that it knows the sequentiality of the data.
Not exactly indexing, but it's the kind of metadata of the data which is stored in the cluster. Not exactly indexing of the data, but data about the data that if file X was 1 terabyte and that has been divided or distributed across 10 nodes, so which are those 10 nodes which are keeping my data? So that information is kept at the name node. And so say if a file is divided into 1 to 10 blocks, so where block number 1 is lying, where block number 2 is lying, and things like that.
Okay.
Okay. So I think I got a ping from someone. Yes, reference to the data. Okay, so Chand has a question reference to the data. Sorry, I am not able to get a question, Chand. Could you rephrase it? So Chand, you can just rephrase and ping your question again. By the time I'll just proceed and read your question again. So now I hope everyone understands the distributed file system with a single namespace or for the entire cluster. And I'll be talking, we talked to the cluster with the namespace as I gave you example previously. And how the data is read, we'll look into that thing. As I told you, the system is created assuming you write once and read many times. So your files. Yes, Basha. The metadata, so Basha has a question whether what is this metadata. So yes, definitely metadata is nothing but the reference to your real data. So where your real data is lying, how your real data is lying, how your real data is divided across different nodes. This is the metadata which is stored by your name node. Karthik also sent me some question. So Karthik asked, I believe he was asking. Okay. Yes. So Karthik is just rephrasing what Basha was saying. Yes, and the answer is yes. So the name node contains your metadata of the system of your data, and I'll make that quick, right? Okay. Before moving to this slide, let's look at this slide.
So the name node, so the name node sits in front of all the other block nodes, right?
Yes.
Name.
Yes.
So will that be a contention, like all the requests has to go to the name node to find the namespace? How can we solve that?
So all these things are covered over here. If you know, so this slide talks about those things, how the data processing happens. And this slide will, okay, so this slide will answer your, how you read the thing with the help of name node.
Right.
It. So I need to explain the system before I jump into those parts. Sorry for that.
Sure.
Keep on asking those. The questions make the system interactive. But you have to just wait for some more time to get it answer. Okay, so I think the question was raised. So let me switch back. I'll skip 2-3 slides. I'll come back to them to answer the question which was raised by you people. So Amish, I'll put you on mute. So okay, I'm skipping 2-3 slides. I'll come back to them to answer your question. So this is my file. Which is of say size 64 into 5 MB, and as I told you, the data is divided into blocks, and the block sizes are by default 64 MB in Hadoop 1.x and 128 MB in 2.x. So our data is divided into blocks. So this file is divided into 5 blocks, 1, 2, 3, 4, 5, and each block is of size 64 MB. So when I'll be putting this file into my ecosystem or in my cloud, this is how your slide data is really placed into the cluster. Your first block would be placed at some location at some disk. This is all decided randomly by your name node on different criteria. And your second and third copy of the same block. Second and third copy of the same block would be kept in some other rack. Okay, before that I have to tell you a few more things. So this is my cluster. This is my cluster, whole cluster. I am assuming that there's only one data center. And this is a picture of your one data center. There's no other data center of my cluster, but practically you might be having different data centers also. But this example is assuming you have only one data center, which has 3 racks. Each rack has 4 machines, and your 4 machines are displayed over here: disk 1 to disk 4 in rack 1, disk 5 to disk 8 in rack 2, and disk 9 to disk 12 in rack 3. So this is a cluster. I want to put one file into this cluster. The file can be divided into 5 blocks. There is a file size. File size 64 into 5 MB. So the file is divided into 5 blocks while I'm putting this or putting this file into the cluster. So block 1, the star 1 is placed randomly. The first the first copy of the block is placed randomly in any of the disk across the cluster. The second and third copies of the block are kept in another rack, not in the same rack where your first copy was kept. Can anyone guess what could be the reason why such a kind of complex thing is happening at the back end? Why the second and third copies of the same block are not kept in the same rack 1? Instead of that, they are copied to some other rack.
For the rack failure, like if rack 1 fails, you have a node failover.
Yes, perfect answer. So this helps you to achieve what we were talking about over here, making our system efficient and reliable. So if rack 1 fails, your data is still safe in some other rack. But the probability of 2 racks going down in the cluster is very less as compared to, whole rack going down. High availability, yes. Second thing is, why the second and third copy of the data is kept on the same rack rather than the third copy of data 1 has placed into somewhere in the rack 3. Now here comes the network cost. When I'm copying the data copy or data transfer across the racks is costlier as compared to data transfer inside the rack. And data transfer across the data center is much higher as compared to data transfer across the racks as compared to across the nodes inside the rack. So copying the data from disk 1 to disk 6 is very costly as compared to copying the data from disk 6 to disk 7. So if I have to copy the third copy or the third replica of block 1 into disk 9 or disk 12 or somewhere in the rack 3, that would have been the costlier operation. So to reduce that network cost while writing, Chand, I'll just read your ping. To reduce that network cost, the third copy is kept on the same rack where a second copy was kept. But the second and third copies are always kept on the rack on which the first copy is not kept. So by this we achieve the high reliability in the system, as well as my data is divided into blocks, and the information of these blocks, where these blocks are lying, where the block number 1, block number 2 and 3, so on are lying, this all information is stored in the as a metadata in the name node. Name node will never store any of your data. It will just store metadata of your data, and this is the metadata which is stored in the name node. That is which are the blocks associated to this file F, and where are the copies of those blocks are lying. So the copy lying in disk 1 or disk 6 and disk 7, this information would be stored in the name node. So we talked about something called name node, we talked something called data nodes. There was something also displayed as secondary name node. I'll just come to that in some time. So Chand is the technique of achieving high availability using redundancy. Yes, redundancy is used to achieve your high availability in the system. Now let's see. Let me put the other data. So this is a block 2. So the first copy of block 2 is kept at disk 6. Can anyone guess where would be the second copy and the third copy of block 2 would be placed?
Either on rack 1 or rack 2, rack 3.
Yes, that's a perfect answer. So it will be kept somewhere on rack 1 or rack 3, but definitely not on rack 2. And I hope now you can understand the reason. So it has been kept on rack 1, on disk 2 and disk 3, and similarly for the other copies. Does this make sense to everyone?
So I think the same data, I think right now we talked about the distribution of one file of 1 terabyte across multiple nodes in the cluster, right? So maybe I think you also talked about some use cases of like, Amazon updating and things like that. So when we do any update to this 1 terabyte of data, so now I think it has to be kind of like synced in all these different replicas across the other racks and clusters, right?
Okay, I think you raised again a good point. So as I told you in the previous slide, Hadoop assumes Hadoop, while this is the assumption behind, these are the 4 assumptions which you have to always keep in mind. Write once, read many times. This is the assumption on which Hadoop ecosystem is created. So updates are not possible in the system. Updates cannot be done in the system. Hadoop as a file system does not support updates.
Okay, so it's basically for a read operations, which actually is efficient read and processing multiple, very large amount of data.
Yes.
I think that's where the Hadoop comes into.
Yes. So that's the reason I told you transactional systems. Hadoop is not used for your daily transaction system. It is a system used for data processing, batch processing, and real-time processing nowadays. But for transactional systems, still Hadoop is not a preferred choice across the industry. However, people are now started moving on to Hadoop ecosystem for transactional queries. But how that is achieved, the first class would be too early for me to explain those things. But definitely I will explain you that thing. How that is.
Yeah, I think it makes more sense for the read of multiple nodes and things like that for just a processing sake. I think it makes sense.
Yeah. And to update, even if you have to update the data, the fastest way to update the data is delete the previous data and write the new data, whole data. That would be much faster as compared if you update the data. Writing and reading is very, very fast in the ecosystem, and when we write terabytes of the data and if you update something, it's much faster for us to delete the whole previous terabyte of file, 1 terabyte file, and rewrite that file in the ecosystem. So for as updates are not supported in the system, you delete the previous data and write it again. That will be much faster for you. Okay, someone also okay. So Chan had a question that is already answered. Okay, so this is a picture of the system. There's something called name node which contains the metadata of the system, and the metadata is now, I hope everyone can understand what is the metadata I'm talking over here. It's the data about the data, which blocks are lying where, which are the blocks created for a file, which are the blocks associated to file, how many blocks a file has, and all those things. And this name node only has the data. It never contains the real data. And this is the master of the cluster. So the everyone of you belong. Okay, does everyone of you belong to India? Or somewhere?
Yeah, I think so.
Okay. Yeah. Okay. So I'll give you one good example. So this name node is kind of a Ferrari, and data nodes are kind of taxis, yellow taxis running in Bangalore or Mumbai. They can fail anytime, but even if they fail, the data is replicated across different data nodes. So these are commodity hardware. Data nodes are kind of commodity hardware, and your name node is a kind of Ferrari which is running your whole cluster. This is a master costless thing. And so name node would be having very, very good configuration in your cluster, but your data nodes could be of any configuration, and a kind of commodity hardware. So even if they fail, our system will keep on running. Your data would be keep on processing with the help of replication factor in the system. And how the but the name node should be of good configuration, and if the name node fails in the current system, in 1.x, we have to manually transfer it to secondary name node, But in 2.x, so here 1.x and 2.x are different versions of Hadoop. There are some drastic changes in 1.x and 2.x. My slides would be talking about 1.x, but I have dedicated slides which talks about the difference in the new things in 2.x. But in this PPT, which I'll be covering, which I've right now opened Hadoop basics, we are just covering. I'll be explaining everything in respective of 1.x. But in another slide of yarn, I'll explain you how the 1.x differ from 2.x and what is yarn. So in 1.x, there's something called secondary name node, and this secondary name node is that keeps on copying the data from the name node and is a kind of replica of the name node. So if the name node goes down, the secondary name node takes care of the system, but this activity of activating the secondary name node is manual, and there's a manual intervention which is required, and some of the data loss happens in between. So in 2.x, this is again handled with the help of secondary name node concept is removed, but there's something similar to secondary name node, and the coordination between these things happens with the help of coordinator called Zookeeper. So files are broken up into block sizes. I just explained it to you, and the typical block size by default is 64 MB. Each block is replicated on multiple data nodes. I hope now that is clear to everyone. And intelligent clients, so clients knows which block is lying where with the help of metadata stored in the name. Okay, so before moving ahead, let me explain a few more things. Again, this question which you people would be asking a lot when I'll be really showing you Hive and big selecting. So yeah, you can see the two graphs over here. One is a red one and one is a blue one. Blue one is your traditional databases like Oracle, MySQL kind of things, and the red one is your Hadoop. So you can see the time taken by Hadoop ecosystem to process your data. So this x-axis is your data size, and your y-axis is the time which you require to process your data based on the complexity of the data. So your traditional databases are much efficient if your data size is small. So if your data size is few GBs or kind of that, your traditional databases would give you much better performance as compared to Hadoop. But as the data increases, the graph is almost vertical for your traditional databases, and that is where the bottleneck is coming nowadays. But with the Hadoop ecosystem, when your data grows, your time to process the data is not increased in the vertical fashion. That is not a vertical line of 45 degrees or 60-degree kind of line. And this, so this is an intersection point where you would be using Hadoop. If you are somewhere here or prior to this, Hadoop is not a choice for you. You are good enough with your traditional databases. So any questions about any questions till now about the reliability of the system, the replication, the blocks, how the data is divided, or the parallel processing, how the parallel processing is achieved, that I'll explain. But the parallel processing and anything related to that, any questions?
So I think from a high level, the data flow from a client to access the data is like a client will talk to a server which actually has a name node, and the name node actually has information about where the data resides,
Yes.
and then goes and picks up the data from the cluster of blocks, block nodes.
Perfectly fine. Yes, perfectly fine. Yes. So if I have to read some data or I have to write some data, it's same thing happens every time. Even if I have to write some data, I contact the name node. Name node, I have to write this file. Tell me where to write. Name node will tell me write on data node 1, 2, and 3 the block first. Data node 3, 5, and 10 the block 2, and so on. So when the name node tells me, name node also stored that metadata in it, and I as a client then talks to those data node and write the real data. And if something failure happens, how that is handled, I'll explain you.
Okay, got it. Thank you.
So these are the different distributions. I hope you by now you would have heard definitely Cloudera, Hortonworks, Mapr, Pivotal, HD, IBM. So these are different distributions or flavors of Hadoop available in the market. We in this session, whole session, will be talking about Hortonworks. This is 100% open source version, much parallel to Apache flavor of Hadoop, and that's the reason I prefer Hortonworks. So in all our sessions we'll be talking we'll be looking into Hortonworks, but the queries, the code, everything would remain exactly same. Even if you want to run on Cloudera flavor or Mapr flavor, you can definitely run them. But we in the session we'll be talking about Hortonworks. So these are different flavors of Hadoop available from different vendors. So these vendors package the different things into single single box and market it. So Hortonworks is 100% open source, and that's the reason I prefer it. Cloudera is again widely used, and I hope definitely you would have heard at least Cloudera and Hortonworks, if not Mapr, Pivotal, HD, or IBM. So all of them have different features, but these are different flavors available in the market. We're just looking at the slide. So this is a strategy which I just told you in the previous slide 5-10 minutes back. One replica on the local node. Okay, so on the local node. So when your name node tells you where. So when I'm writing this block 1 on somewhere, again the proximity or locality is always taken care in the system. So if I'm sitting on disk 1 and I'm trying to write it, and if there's some option to write on the disk 1, my name node will always try to write the first block on locally on the same node. So in that case, name node will return me that write your first first copy of the block on the same node, that is disk 1. But this locality is always taken care when you're writing the data, to reduce the network cost and the time to write the data. So one replica on the local node, second replica on the remote rack, third replica on the same remote rack, and additional replicas randomly placed. And when I have to read the data, again the locality is taken care. If I as a user ask name node, man, I have to read the file F, this file, tell me where the file F is lying. So name node will return me only one copies. So in that case, name node might return me something like this. Go to disk 1 to read block 1, go to disk 2 to read block 2, go to disk 8 to read block 3, and go to disk some as this to read block 4 and 5. And in this case, while name node is returning me the addresses, again the locality will be taken care to reduce the network transfer of the data. Here I am just talking about the read of the data, which you will be really doing. You won't be reading your petabytes of file. You will be processing the petabytes of file, and the processing is done locally. But if the read is to be happen, so the locality is again taken care. But practically you will not be reading the petabytes of file. That will not make sense to you. You can't read that file. You will be practically processing the file. Okay, there was some disturbance. I thought someone had some questions. So now this slide would make sense to everyone. Anyone has any questions on this side? Failure, replication, large, fault tolerance. I was watching one YouTube video, and I found a pretty good, interesting example. There was a guy who was giving some conference on Hadoop only, and he was giving conference on some NoSQL word or something, but he gave a pretty good example. So as you know, they have the data replicated across the cluster, and they were maintaining 3 copies of the data, and the data was replicated across different data centers. So their data was not only in a single data center, but their data was divided across distributed across data centers. So he gave a pretty good example. He and one of his friends were supposed to party on Friday night. They both were working in different companies. However, fortunately, both the companies were storing the data into same data center. The friend who was using Hadoop kind of ecosystem didn't even knew that the data center was down over the weekend, but the other friend with whom he was supposed to party, he was wasting his whole weekend at his office to resolve the issues because the data center was down and none of their clients were able to access the data. So this is how the replication helps in reliability of the system and making the system fault tolerant. There are other features also, how the system is fault tolerant if the data node fails or some data is lost or corrupted, how that is taken care. I'll explain you those things. But this is one of the major thing, how the failures and the faults are basically tolerated in the system.
Yeah, can you explain, like, from a use case point of view? I basically divided the 10 terabytes into like 10 different blocks, and each block actually has 3 copies on different nodes in the cluster, right? So from a point of like retrieving the data and like making them all in one piece, because your one rack might have block 1, block 5, block 7, block 9, and other racks might have like block 2 and 3. Where is the logic that or intelligence to assemble them in the right way so that the data is integrated?
Okay, so that was Umesh, right? Yeah.
Yeah, this is Umesh.
So Umesh, first thing, practically you would never be segregating the whole data. If you have written the data, you will be processing the data practically. You will not be reading the petabyte of file will never make sense to anyone. You can't do anything.
Like some query, right? Like,
yeah.
They're doing some query and then getting some data back, not the whole data,
yes.
Some query of the data has been returned back.
Yes. So what will happen in that case is, say I ran a query on this data, which says find the, so say my data is again say some sales data, and I ran a query select max selling price from orders table. And this order table is nothing but this file. It is divided into 5 blocks. Okay. So what will happen in the system is that query will be sent to disk 1, disk 2, disk 8 and 2 more disks. Okay. Disk 1 has the copy of block 1, disk 2 has a copy of block 2, disk 8 has a copy of block 3, and 2 more disks will have a copy of block 4 and 5 online. That query might have gone to disk 1, disk 3, and disk 11 also. But that query can go to any node. But how that is taken care of, we'll explain those things. But say that query has gone to disk 1, disk 2, disk 8, and 2 more disks. So that this data what is there in the block 1, block 2 and block 3 is never transferred across the network. I have only transferred that query which is not more than few bytes, that is select max SPR selling price from the orders. So from disk 1 I selected the maximum one, from the disk 2 I selected the maximum one, from the disk 8 I selected the maximum one, similarly from disk 12 and disk some other disk where the 4 and 5 are lying. And this single records are then transferred to the network, and these are consolidated on some other node. How that is done with the help of MapReduce framework. I'll explain you all those things. And then that is consolidated on some other node. And on that node, out of those 5 rows, I'll be just finding out the maximum one and will be returning to you.
Okay, so the benefit here is basically you're doing a small subset of data that you're working on per disk, and that's why the faster retrieval, right?
Not only faster retrieval, I have reduced the I/O because my block sizes are large. Secondly, my data is divided. Again, I have reduced the I/O. Third thing is my data is divided across different data nodes, so I have made the system reliable. As well as some say disk 8 is down, so I can even process it on disk 10. Or if say disk 8 is not down, but still my data has got corrupted, I can send the query again to disk 10. So everything is managed in a cluster with the help of job tracker and task trackers. And as my data is divided and distributed, basically, I can do a parallel processing. I can use the processing power of different disks. So if say disk 8, so say if my data is lying on disk 6, that is block 1 and block 2, or both are lying on disk 6, but if I send a query to disk 6 for block 1 and block 2, my CPU might not be available on disk 6 to process both the things at the same time. So I might be waiting to get that output from the disk 6. So all these complexities are handled with a framework to divide your processing power across the cluster and process your data in the faster achievable time.
And since you are only passing the program to each node, you are actually saving on the network bandwidth.
Yes. I am never transferring the data across the network.
But you might, will there be a chances that since like disk 1 has like node block 1 and disk rack 2 actually has 2 copies of block 1. So will there be a chances that the same data, same query is executed on the same set of data on different disks? Basically, I'm saying like I don't want the query to be executed on block 1 on different racks. I want to only execute only one time because I don't want to be reading the same data and querying them again on block 1 on disk 6 and 7.
That will never happen. With the beauty of the framework, how that is done, I'll explain you. But with the beauty of the framework, your query would be ran only once on one block. Although they are replicas of the same block lying across the cluster, but the beauty of the framework is your query will be running on all the blocks of the file, but only once on each block.
Unless that disk is corrupt and it has to reassign.
Yeah, unless unless the disk is corrupt or the network has failed or the disk has gone down or the output is not correct or things like that. Unless those kind of complexities.
Yeah. Okay.
Any other questions? Anything else? Okay. So let's move on. So now I hope this makes sense to everyone. A large application failure, fault tolerant. Okay, so the default replication factor is 3 as I told you, but technically you can change it. Everything is configurable in this world. All the things would be configurable. I'll show you some of the configuration things, how that is done. You can change all those things, but C is the most risky. But on the large clusters, when you are talking about thousands of node cluster kind of things, you can increase the replication factor. Okay. So in the previous slide, we talked about name node, data nodes, and things like that. So here, little extension on that slide. So there's something called name node which contains the metadata. I, as a client, when I say I want to read some data, I query name node returns me where the data is lying. I, as a client, will basically read that data from the corresponding data nodes. So these are your yellow color racks, the green colors are your data nodes, and the data is, separated across different racks and different data centers, kind of thing. So name node always contains your metadata, never contains your real data. That is a list of files, a list of blocks for each file, list of data nodes for each block, file attributes like creation time, replication factor, transaction logs, like your, when the file was created, deleted, and all those things. And how the name node is able to maintain that? Because all your requests are transferred via name node. All your read and write requests are transferred via name node. When I have to read something or whenever I have to write something, your request will come via name node. And that's the reason I pointed this name node as a Ferrari this name node requires high processing power, and no one wants to waste this processing power in mundane tasks like maintaining the data, or maintaining the real data, things like that. It manages the whole cluster, so it knows where your data is lying and things like that. And this node requires high processing to respond to all those queries and to maintain the metadata of the cluster. So this is always of high configuration, and as all the read and write requests are transferred via name node, this node can store such kind of metadata and maintain this kind of metadata. Any questions? Anything? Okay, so data nodes, as I was keep on saying, data nodes are nothing but kind of commodity hardware. So they store your real data, that is real blocks which are divided for the file, and data pipeline I'll talk in detail. Okay, so this is how your cluster looks like. Your cluster has name node, secondary name node. Secondary name node is nothing but your replica of your main name node. When your name node is down, your secondary name node is up. But that is and that is done physically in 1.x, but in 2.x that can be automated. And your data nodes are, as shown in the green over here, your real processing also happens on data nodes, and the real data is also stored on the data nodes. So we have looked into name node.
So I think who assigns the namespace on the client request?
So namespace is nothing. When you configure your system, at that time you give some namespace to your cluster, and that is used across the cluster. So that is while you're installing.
I understand from the point of name node, namespace, and mapping into the different block. I understand that part, but there has to be, like, from a client request, that has to be intercepted to kind of like change into a namespace terminology to understand, okay, this client request is coming from this one, and I have to look at this namespaces from this name node. How does this mapping is done from the client request to the namespace?
So, see, whole cluster has a single namespace. If I have 1,000 node, if I'm sitting on the 1,000 node cluster, the whole cluster would be having same namespace for Hadoop file system. So when I have to interact with the Hadoop file system, I'll be giving the same namespace. I, as a user, it's transparent to me when I'm querying some file. I am not worried about where that file is lying.
Yeah, from a user point of view, it's not, because, like, let's say I'm a user, I'm saying, okay, like, give me all the pictures of Tendulkar, right? And let's see, if you are putting Tendulkar in like so many different servers, and it has to go and get all the data from all these servers, right? So from a user point of view, you're just doing a query literally, right? But when it comes to the Hadoop ecology,
let me answer that question. So when you go to the name node, it doesn't mean you are going to look up the name node's namespace and query that. When you run a query, you always start with HDFS, and then you give the option that you want to do. And that HDFS command is nothing but invoking the name node with the command.
I see.
So you don't have to know exactly what the name node is, where the name node is. The HDFS command will literally take it to the name node and render it to all the data nodes that needs to process it.
So basically, when we create the topology, you have to have a namespace that we know exactly where to go on, and we give this namespace when we do query from our, when we call the HDFS with the namespace, right?
No, you don't have to give any namespace when you query or do anything.
So basically, when you interact with the system, you can give the namespace, so that I'm not sure who actually Till now, I can't recognize all your voices. So, okay, that was Karthik. So, yeah, Karthik, you can even give the namespace while you're querying from SDFS. You can even skip the namespace. So that's again optional thing when you're dealing with Hadoop or SDFS commands. I think the Amish, your confusion is when I, as a client, query the system, how the topology comes in picture, the namespace is being, transferred to the corresponding IP address or those things. Is that your question, right?
Right. Because from a client point of view, he doesn't care about the namespace, how your technical architecture is set up. He don't care, right? But as a developer, I would need to understand like how is that mapping to a specific namespace.
Yeah. So the first thing is there is a single namespace for the whole cluster. If there are 100 nodes in the cluster, the namespace would be one only, a single namespace. And I, as a user, always interact with one person called name node. But if I have to read or write something, if I have to trigger some process, I interact with the node which is running my task manager. What is task manager? Don't worry about for time being. But I interact with one node which is running my task manager, which is normally the name node only. Again, in most of the scenarios. So I, as a user, when I'm triggering some query, I interact with only one node, which is called a task tracker or a name node, and I just send the query and I just send the data. So if I say I want to search the images which contain Tendulkar images, so I just send a query, and that query would be distributed across the cluster with the help of name node or task tracker to do the processing. So here, the configuration or the topology to convert the domain names or the name node to the corresponding IP address is all hidden inside the cluster only. So you, as a user, always interact with one person called name node or task tracker. And when you are interacting with your name node or task tracker, you are sitting somewhere on the Hadoop cluster only. So when you, as a user, are interacting with system, with the system, you are sitting somewhere in any one of these nodes. That node might be your data node or the name node. And when you are triggering some query, that query would be going to your name node or the task tracker, and then the task tracker will be managing all the further processes. And how that is configured, there is a configuration file called there are 2 or 3 configuration files which maintain all those things, where your name node is, where your job tracker is running, with the corresponding the IP address and the port on which it's running.
Okay. So it's basically like broadcasting to the name node, and the name node will actually do all the work to do a query against all the different blocks and things like that, right?
Yes, for timing, just assume it's always the name node, but there's something called task tracker also, which I'll explain in the next few slides, and that takes care of the basically distributing your processing logic across the different nodes where the data need to be processed.
Okay.
Okay. So okay. So till now we have seen something called name nodes, something called data nodes. So in this slide I'm introducing 2 more new terms, something called job tracker, as I was speaking right now, and the task tracker. So job tracker normally runs on a name node, but it's not mandatory to run it on a name node. Your client might be running on some other node, but that again node will be requiring some high processing power, and why I'll explain in a few minutes. And there's something called task tracker, which is running on all data nodes. Each data node will be running one instance of a task tracker. So this task tracker is basically maintaining or tracking all the tasks which are running on a data node. Okay, so this would require time, and we are almost, we are just 10 minutes left. So I'll not start this new thing, but let me give you an idea what is job tracker and task tracker. But I will look into this thing. This will require half an hour at least to cover up this thing. So these 3 slides are interrelated. So we will touch base this thing tomorrow, and this slide will answer your question, Umesh, which you were asking previously, or previously how that logic of that thing. So this slide will answer your question. I'll not go to this. We'll talk about this thing in detail tomorrow. But let me explain what is job tracker and a task tracker. So all your request, of the processing of the data goes to your task tracker, which is displayed on this slide. Normally runs on a name node, but it's not mandatory to run it on a name node. It can be running on any other powerful machine. And then the job tracker basically distributes that processing logic to different nodes where that real processing need to happen. And that processing logic goes to a data node, and on the data node there's some JVM instance called task tracker which is running up, which really runs your your logic on the data which is lying on the data node locally, and returns only the processed output to the which is used by the user. So there are two phases in it. While running your whole logic, there's something called map phase and there's something called reduce phase. I'll talk that thing in detail again. So all your data need to be divided into map and key and value pair, and based on that key and value pair, all your data processing happens. I hope everyone of you understand the key and value pair, hash maps, and hashing related things. If anyone of you don't understand, I'll explain those things in detail, but I hope everyone would be understanding, as you all are from Java background and working in this industry. Anyone who do not understand the hashing or key value pair or hash maps kind of thing? Okay, the silence, I'll assume everyone understand it. So all your data is divided into key and value pairs, and based on those key and value pairs, the data processing happens. How that is done, we'll talk about those things in the MapReduce slide. But this is how your logic is divided across the cluster to do the data processing. There's a central manager called job tracker who divides or distributes the logic to the different task trackers, and those task trackers really run your logic on the data and returns only the processed data. So does it answer your question partially, Umesh? But I'll explain your question totally tomorrow. But does it answer your question partially today?
Yeah. This is for how do you guide the distribution of the task, right?
Yes.
That question.
Yes, and okay, I'm not going into detail how that is done because we will not be able to cover that in the time.
Right.
But say now when this logic is transferred, at that time it is taken care with the help of now the name node knows where your data is lying, and the task tracker knows where your processing is happening. So there are two managers in the cluster. One is called job tracker and one is called name node. So now job tracker knows where the processing is happening. So if data node 1 is busy with some processing of some data, and the RAM sizes and the CPU of that node does not suffice enough to do further processing till the previous processing is done, so job tracker will not send the logic to process another data on that data node. However, it will choose another data node which is having the copy of the data to do the processing because data node 1 is busy. And this is how the system, parallel processing was achieved, and the data and the processing distributed across the cluster. Second thing is, as the name node knows where the different copies are lying, so job tracker continuously interacts with your name node, find out the copies of the data, and transfer your logic to the corresponding data nodes where the processing can be done based on the availability of the data nodes and based on the availability of the resources on those data nodes. And while this everything is done, task tracker job tracker also maintains different statistics. Say while a part of the logic which is ran by the data node 1 is not being completed and it's getting timed out. So next time it will not send the logic to data node 1 again for all the copies which it is having. Rather than it will choose some other node to maintain the reliability of the system. If say while processing the node X goes down, the job tracker, these task trackers keeps on sending the heartbeat signals to job tracker, and by that way job tracker keeps on knowing that the task tracker is doing the job. If the heartbeat signal is not received by the job tracker, it will reassign the task for that block to some other data node where the copy is lying, and this is how the fault tolerance happens. How that is done, I'll explain you over here. Any other questions anyone has before we wind up for the day? Any questions which anyone has? So we'll talk in detail about the job tracker and task tracker in tomorrow's class. But if anyone has any questions, okay. So there are few things.
Go back to the previous slide.
Yeah.
So I'm just trying to understand this conceptually. Like, you talked about data nodes and name nodes. So that means each name node, Hadoop name node, will actually have a job tracker and the name node, right? Basically, there'll
be a single name node in the cluster. There's only one name node in the cluster. There are hundreds or thousands or tens of data nodes, and each data node is running a task tracker.
Okay, so each task tracker will have reference to a data node. Basically, it knows like, basically a task tracker is for the data nodes, and it knows like if data has been processed by that particular data node, then the task tracker will actually have reference to that, right? Is that right? Yeah, go back to the screen. I'm trying to understand the diagram there.
Yeah.
Here,
so because
we have a box for task tracker and the data node.
This is whole your data node. This is your data node. This is your one data node. This is your second data node, and so on. So this data node has your real data. So this is your data. Basically, this is your whole data node. Basically, this green color box is your whole data node, and this data node is running one JVM instance also that is called task tracker, and there's one node, normally name node, which is running your one JVM instance called job tracker, and this name node also contains your metadata. So this is your metadata, this is your data, this is your real data, and these are the JVM instances running on these physical machines. So there are three physical machines shown in this diagram. One is your name node, which is this physical machine. The two physical machines, your data nodes, that are shown and below in the diagram.
Mm-hmm.
Make sense?
Yeah, I think when you see some I think conceptually I think it makes sense, but I think when you see some samples, it will be clear. I think.
Yeah, definitely. We'll look
because I see that there's a diagram.
Yeah.
Right. The arrow going from job tracker to task tracker. That means each job tracker will have
again there's only one instance of job tracker running in the whole cluster. Only one instance of job tracker.
That means like there's a 1 to n kind of relationship between job tracker to task tracker.
Task tracker, yes.
Okay,
yes.
And then name node to one to many. So data nodes.
Yeah, only one name node in the whole cluster, only one job tracker in the whole cluster. Each task tracker on each data node, one task tracker on each data node, and each data node will be running its own task tracker and containing its own data. What data is lying where is maintained by the name node, and the job tracker JVM might be running on the name node or some other node, and that job tracker will be maintaining or communicating with all the task tracker JVM instances which are running on your data nodes and maintaining your data processing, managing your data processing, basically bookkeeping all your data processing work. We'll look in detail how that is done, but there's just a picture.
And there should be some kind of a view for this, for a given query from a Hadoop ecology, how many job tracker, how many task trackers got executed, and what is the data node? Is there a view for that?
Yes, definitely. Yes, you can look all those things. Yes.
Okay. Cool.
Okay. Any other questions? Anyone else? Okay. So tomorrow we'll look into the detail of the job tracker and task tracker, as well as I would be sharing all these PPTs with you, and if you require if you by any chance if you miss the classes and if you want to look at the recording, you just drop an email to admin@designpathshala.com and they will help you in accessing the recording. and I will be requiring your Gmail IDs so that all these PPTs I will be sharing up at the end of the logical completion of the thing. So at the end of the logical completion of the thing, I'll be sharing these PPTs. Prior to the class, I'll not be sharing the PPTs because if you move on to the next slides, sometimes it's a little confusing for others to maintain the things. So I'll be sharing all these PPTs, but only after completion of the logical things.
How many sessions? I think I kind of missed that.
Umesh, it depends on grasping of your things. We as a design Pathshala never gives particular dedicated 20 hours, 30 hours, 40 hours kind of thing to people. We believe in completion of the things. So normally, based on the experience that this batch have, I assume it will take 25 hours around for you people to cover all the things. In freshers kind of batches, I might even take 35 hours also, 35 hours, 40 hours also. I might have reviewed some things, I might post in details also. So, but based on the work in this batch I have, I think it would take around 25 hours to cover up all the topics which I was talking about, including the hands-on projects, and including the hands-on exercises which you will be doing. The project we'll be discussing at the end of the session. So I got something. Sorry, my computer microphone is not working. That's why I'm quiet, but I will fix it tomorrow. Sure, Basa, you can fix up my microphone tomorrow and test it out. And I will be requiring your Skype IDs as well as your Gmail IDs so that I can share you the PPTs. I'll be sharing you all the PPTs on the Google Drive, and Skype ID I'll just be requiring up. Sometimes someone get disconnected or there's some issues while joining and things like that. So it's pretty easy to communicate over Skype. So I'll create a group over the Skype for 5 of us, so that some communication need to win. That could be done easily if people are not able to join into GoToMeeting or facing the GoToMeeting. So for that, I'll be requiring a Skype IDs and the Gmail IDs. So you can just take me those things, and I'll share you the PPTs once we complete this thing. And I hope every one of you have the laptops, and do let me know the configuration of a laptop. Does any one of you have a laptop with less than 4 GB kind of configuration?
Is there any specific thing I'm going to install it before we come in tomorrow? Like
no, Rajesh, I'll be sharing all the software which are required, all the VMs and things like that, which we'll be running our programs and doing the hands-on. I'll explain you how to install those things, everything. I'll share the softwares on the Google Drive. So today I'll be sharing those things. You just download those things. Downloading of that VM, those are 510 GB things. So you can download it on your PC. But how to install those things and things like that, I'll explain you in the class.
So we need the email ID from the Gmail.
Yeah, so that I can share on the Google Drive. Yes, that's the reason I'm asking the email IDs.
Yeah. I will send it to you. Yeah.
Sure. Okay, and I hope every one of you has a laptop with more than 4 GB of RAM. Otherwise, it will be little difficult for you to run the virtual machines on your laptops. Sure. So I'll just then go one by one. As today is the first session, I'll just get little bit feedback from you people, and if you want to change anything or want to do anything else, or you were expecting anything else, so that we can change that thing in the next class. So Basha, you can ping on the chat window because your mic is not working. I'll hand it over to Karthik.
Sorry, sir. What do you want?
I was just anything which you want to say about the class, anything which you want to change, was it good, well, okay, fine, anything you want to change, anything you want to, anything which you want to say, because this is the first session,
Yeah, overall it was good. The only feedback I would have give you is that because people are jumping ahead and asking questions that are to be covered in the next few slides, it's good to go immediately to those slides and explain the concept so that we don't keep having the same questions again and again.
Okay.
That way it will help us understand when you give the concepts upfront, it is easy to grasp what you're saying. So that would be my only feedback.
Sure. I'll take care of that thing. Anything else? Any changes which you want to do, or anything else which you are expecting out of the session? Anything?
No, everything else is good.
Okay, sure. Okay, I'll hand it over to Rajesh.
I don't have any suggestions. I'm good so far.
Okay. Umesh, anything?
I think I'm pretty good. I think your explanation is very clear. So I think when you go a little bit more on the, I think conceptually I think I can understand. So I think when you go a little bit more detail, I think I'm going to have some more questions.
Yeah,
I think
definitely.
I'm good for now.
Okay, sure. And Basha, I think your mic is not working, so I'll just, we can talk to you tomorrow, or you can ping it on the chat window. So thanks everyone for your time, and let's meet tomorrow same time.
Okay, thank you.
Thank
Bye.
you. Bye.